Welcome to Math TV with Professor V. This is video lecture number 17 on Introduction to Polynomials and Polynomial Functions. So we're starting Unit 5, having to do with polynomials and polynomial functions. We're going to get into multiplying polynomials, dividing them, factoring them, all sorts of good stuff. So first things first, some terminology or definitions that we need to set straight. When we talk about a term can be a constant, or it can be a variable, or a product of constants and variables. Let me show you some examples, okay? So a term could be something like 5x. That's a term. It's a product of a constant and a variable, or just the number 7, or y squared, or 2xy cubed. Those are all terms. All right, a monomial. A monomial is a single term. A binomial, that's when you have a sum or difference of two terms. So for example, a monomial are all of the terms, examples are all of the terms that I just listed on the right side in purple. A binomial might be something like 2x plus y, or x minus 3. Those are all binomials. A trinomial, again, is the sum or difference of, yes, you guessed it, 3 terms, okay? So just add or subtract another one on there. And then the term that you're going to hear a lot is a polynomial, and a polynomial refers to the sum or difference of any number of terms. Any number. So that means a monomial, a binomial, a trinomial, those are all polynomials. Okay, so polynomial is a more general umbrella. Any number, it's a polynomial. Okay, when we refer to the coefficient of a term, that is the constant part. And we'll be working on identifying coefficients of terms in just a second. For some of the ones that I listed over here, 5 is the coefficient on 5x. 7 is the coefficient for just that constant. There's no written coefficient that you can see on y squared, but remember that means it's a 1 since we don't write it, etc. Now, the degree of the term. The degree is something you're going to have to identify often. The degree refers to the number of variable factors in the term. So for something like x to the 5th, the degree is 5. That's pretty straightforward. The number of variable factors, how many x's are in x to the 5th? There's 5 of them. There's 5 factors. So you can basically just look at the exponent, right? Now, if you have something where you've got a couple variables going on, for example, 2xy cubed, the degree of that term would be, what do you think? How many variable factors are in the term? It's actually 4. Because we have x to the 1st and y cubed, so altogether there's 1x, 3 y's. You can just add those exponents together, so the degree is 4. All right, we'll practice that too. Don't feel like you have to be an expert just yet. Now, when we talk about the degree of a polynomial, all you're looking at is the degree of the highest degree term. So the degree of the entire polynomial is the degree of its highest degree term. And later on, when you get into pre-calculus and things, you'll see that that highest degree term controls so many characteristics of the polynomial. So that's why that's how we classify the polynomial's degree. And then the last two terms here we use only for polynomials of one variable. Okay, so polys of one variable only. So no mixing x's and y's, okay? So when we talk about the leading term, that's the term of highest degree. So it's leading. And then the leading coefficient would just be the coefficient of that leading term. All right. So here we go. We're going to look at some examples, just applying the vocab and getting comfortable with it. So first example asks us to identify the terms, the coefficient of each term, what the leading term is, the leading coefficient, the degree of each term, and the degree of the polynomial. Okay, so let's make it organized. All right, we're going to list out each of the terms here. Let me zoom in. So let's list out the terms. And then it wants the coefficient, the degree, and then we'll answer the last two parts after. Okay, here we go. So how many terms do you see here in this polynomial? I see 3. Do you agree? 1, 2, 3. Boom, boom, boom. So first term is 7x to the 4th. What's the coefficient? Why, yes, it's 7. The constant part of the term is the coefficient. Now, what's the degree? Basically, just add up all the exponents on the variables. So the degree is 4, right? You're looking right here. Good. Let's move on to the next term. The next term I see is 5x. What's the coefficient? Good, it's just 5. And the degree might be a little tricky. So the degree, notice here, the exponent that we're not writing on the x that we all understand there is 1. So the degree of that term is 1. Good. And then last term here is -3. Don't forget the negative. What's the coefficient? It's just going to be the term itself, right? There's no variable part. It's all constant. And what's the degree? How many variable factors are there? There's 0, right? So the degree of this term is 0. You can also think of it like x to the 0 is there. X to the 0 would be 1, as long as x isn't 0. Okay? Good. So constants have degree 0. Now, it asked us for a few other things. What did they want, these people so demanding? They want the leading term. Okay, so the leading term is the one that has the term with the highest degree. So right here, term of highest degree was 4. So the leading term is 7x to the 4th. Then they want the leading coefficient. So the leading coefficient, you just snag it from the coefficient of the leading term, 7. And then it wants the degree of the polynomial overall, okay? So if you're going to pick one degree for this polynomial, you go for the highest. So this polynomial is a degree 4 polynomial. Good? Okay, cool. Let's look at one more example here. We have 3a squared minus 7 plus 2a to the 4th. So let's organize everything the same way. We'll do the term, then we'll do the coefficient, and then we'll do the degree. Again, there's 3 terms. Okay, so first term I see is 3a squared. What's the coefficient or the constant part? Good, it's just the 3. And the degree, you can just look at the exponent on the variable. Think how many variable factors are there? It's 2. Nice. Okay, next term is -7. That's just a constant. So when you give the coefficient, it's the term itself, right? -7. And the degree, remember, there's no variable portion here. So there are no variable factors, so the degree is just 0. Nice. And then last one, 2a to the 4th. Coefficient on that? Yes, it's 2. Very good. And the degree is 4. Perfect. So what's the leading term? What's the term with highest degree? Ooh, it ended up being the last one, right? So it's 2a to the 4th. Okay. And the leading coefficient is 2. And then if I were to ask you, what's the degree of the polynomial overall, what would you say? Give the degree of the highest term, sitting right here. It's 4 again. I promise they won't always be 4, okay? Very good. Now, this brings us to an important idea involving like terms and standard form, okay? So when we refer to like terms, that means that we would have 2 terms with exactly the same variable part. Exactly the same. I'm going to write this in just like everyday language, okay? There's more formal definitions. But basically the idea is you would have the same variables raised to the same exponents when you're dealing with like terms. So let me give you some examples. Say you have x squared y and 3x squared y. Yes, those are like terms. However, if you have x squared y and 3xy squared, no. Right? Notice the variables are raised to different powers. The variable part does not match up. They're not exactly the same, meaning you can't combine them. All right, and then standard form is when we list a polynomial in descending powers. Okay, and this is again for single variable only. Not when you're mixing x's and y's or something. Okay, so here we go. First example, we're gonna simplify by combining like terms and write your answer in standard form. So that means they want it in descending powers. So my advice to you is just go on a little scavenger hunt and stay super organized. So, okay, what's the highest power of x that I see here in this whole polynomial? It is -x to the 6th. Do you see any others? No, me neither. So that goes first, -x to the 6th. Okay, what about x to the 5th? We've got 8 here plus 2. So now we're up to 10x to the 5th. Are there any others? Nope. So that's positive 10x to the 5th. Okay, now let's look for x to the 4th. Let's see, we've got -x to the 4th, positive 5x to the 4th, minus 4x to the 4th. So that's -1 plus 5, so positive 4x to the 4th, minus 4x to the 4th. We basically have 0x to the 4th. You don't need to write that though. So your final answer would just be -x to the 6th plus 10x to the 5th. And that's already in descending powers. All right, so remember, if you have like 8x to the 5th plus 2x to the 5th, when you're combining like terms using addition, subtraction, do not mess with the variables. All you're doing is adding the coefficients together. Don't touch the variables. So you just make it 10 and then leave this alone, okay? Remember. We'll change the exponents later. That's only in multiplication and division, okay? But in addition and subtraction, do not touch. Yay. All right, now let's start looking at using some function notation. These are polynomials. So instead of writing f of x, we're writing p of x, but that's cool, same thing. So evaluate p of negative 3 if p of x equals negative 2x cubed minus 4x squared plus 3x plus 1. So what the directions are telling me to do is take negative 3 and substitute it for x everywhere you see an x in the polynomial. So let's go. So p of negative 3. Now listen, we got to put parentheses around this negative 3, okay? So we've got negative 2 times negative 3. Close it, and then you put the exponent outside. Don't put the exponent inside the parentheses. No, no, no. Minus 4 times negative 3 squared. Did you put the 2 outside the parentheses? Oh, good. Okay. Plus 3 times negative 3 plus 1. Yes? Does your work look exactly like mine? I hope so. Then you won't make mistakes. Okay. Order of operations time. Do our exponents first. So leave that negative 2. Now let's think here. Negative 3 cubed. Negative 3 times negative 3 times negative 3. That's negative 27. Minus 4. Now here's where you have to be careful. Negative 3 squared, that becomes a positive 9. And then I have plus 3 times negative 3. That's negative 9 plus 1. Good. Okay, now we can start multiplying. So negative 2 times negative 27. That's positive 54. Minus 4 times 9, so that's minus 36, minus 9 plus 1. Okay, very good. So 54 minus 36, that's going to be 18. 18 minus 9 is 9, plus 1 is 10. Voila. Nice. Okay, so just make sure when you're evaluating and substituting in especially negative values for variables, you're careful with the parentheses because it can affect your answer if you're not watching where those negatives go. All right, next example. For jumps that exceed 13 seconds, the polynomial function s of t equals 173t minus 369 can be used to approximate the distance in feet that a skydiver has fallen in t seconds. Approximately how far has a skydiver fallen 20 seconds after jumping from a plane? My, oh my. I've never gone skydiving, so you tell me how it is. Do they normally exceed 13 seconds? Wow. So S, you'll get used to, especially if you take more physics, chemistry classes, you'll see S is used to describe position. So that's why we're getting used to seeing this to describe distance. And here's the function. You don't have to come up with any equations to use. S of t is 173t minus 369. And they want us to figure out how far, what's S, what's the distance after 20 seconds. So you're just going to plug in or substitute in 20 for t. So S of 20 is going to be 173 times 20 minus 369. All right, so 173 times 20, 3,460 minus 369, and we get 3,091 feet. Yes, put those units on there because you know what? They told us that it represents feet, so then you have to use it. Where did they say feet? I'll show you right here. Boop. All right, very nice. Now, we're going to move on to adding polynomials. Just keep in mind, when you're adding polynomials, it's exactly the same thing that we did previously when we were combining like terms, okay? So, here we have an example. Perform the indicated addition. So we've got two polynomials added together. You can notice here's polynomial 1, here's polynomial 2, and really you can just pretend those parentheses aren't there and just start combining your like terms. All right. So let's see here. I've got a 2/3 xy. Do we have any other xy's? Why, yes, we have a negative 4/5 xy. So to combine those like terms, remember we have to add their coefficients. So here, let's just do some scratch work off to the side. We've got 2/3 plus a negative 4/5, so that's minus 4/5. Common denominator is going to be 15, right? So 2/3, if I multiply top and bottom by 5, it's going to become 10/15. Minus 4/5, I'm going to have to multiply by 3, yeah? This is what is happening right now, people. So that's going to be 12/15, and we're left with negative 2/15. Okay, so that means the coefficient on xy is negative 2/15. Fabulous. Next one, negative 5/6 xy squared. Are there other xy squareds? Why, yes, here is 3/4 xy squared. Okay, here we go. So negative 5/6. I don't need to put the xy squared part. I'm just trying to figure out what the new coefficient's going to be. Plus 3/4. Least common denominator here is going to be 12, right? So multiply this one by 2. Multiply this one by 3. And now I have negative 10/12 plus 9/12. Leave the denominator alone. I've got negative 1/12 xy squared. Good. And then last one, look at this. What's going on? They're mixing decimals in here too. Okay. So I'll just keep this last term with decimals. 5.1 x squared y. And then here's another x squared y. So all we need to do is figure out what's 5.1 minus 3.4. And that is 1.7. I'm just going to leave it like that. If you want to switch it to a fraction, it would be 17/10. But you know what? They left it all mixy, fractions and decimals, so we're just going to copy them. 1.7 x squared y. How can they get mad at us if we do the same thing they did, right? Okay. Very nice. So nothing really new. You can just imagine that those big parentheses around the polynomials are not there when you're adding them together. Now, definition, the opposite of a polynomial. When we talk about the opposite of a polynomial, that's when you take the polynomial and you just multiply it by -1. What does it actually look like when you do something like that? You change all of the signs of each term. Okay, so change the sign on all terms, or of each term. So, quick example. Write the opposite of the following polynomial. So we've got negative x cubed plus 5x squared plus 7x minus 2. The opposite would just be positive x cubed minus 5x squared minus 7x and, good, plus 2. Similarly, if you just see a big negative sign in front of a polynomial in parentheses, you distribute that negative to all of the terms, which is the same as finding its opposite. So if I were to distribute that negative, now the polynomial would be negative 7x to the 9th minus 5x to the 4th plus 3x squared plus x minus 8. Now this might seem super basic. Why are we talking about this? Because remember, subtraction can be thought of as addition of the opposite. So now we're going to talk about subtracting polynomials, and I want you to think of adding the opposite when you're looking at the one that's being subtracted. Okay, so perform the indicated subtraction. We have 4y squared minus 13yz minus 9z squared. And then we're subtracting 9y squared minus 6yz plus 3z squared. So to get things going, what we're going to do is distribute this negative and rewrite the whole problem, but this time no parentheses, right? Because we're going to distribute the negative. Now the first one, there's no negative in the front, so we can just drop the parentheses and move on with our lives. So rewrite the first one exactly as is, and then now I'm going to distribute the negative. So now we have negative 9y squared plus 6yz minus 3z squared. Okay, and then now it's like we're back at one of those problems that we looked at earlier. Just find the like terms and combine them. So we've got 4y squared. Any other y squareds? Here's one, a negative 9. Remember, only combine the coefficients. Do not mess with the variables. So 4 minus 9, negative 5y squared. Okay, what's next? This negative 13yz. Any other yz's? Here you are. 6yz. So that's going to be, you got it, negative 7yz. And then lastly, negative 9z squared, negative 3z squared. So negative 9 minus 3, that's negative 12z squared. Now this is not a polynomial of one variable, so technically you can't put it in descending powers. All of the terms are actually degree 2, right? Did you notice that? But usually if you have one that's mixed, like a yz or an xy, you put that one in the middle, and then you put the squared ones on the outside, usually. Especially when we get to factoring later, you'll see why. Okay, lovely. One more example here with subtraction. So why don't you guys pause the video, give it a go on your own. Notice we've got 3 polynomials here. Oh my goodness, we're getting fancy. 3 polynomials, 1, 2, 3. We're adding the first 2, subtracting the last one. Pause it, work on it on your own, and then watch the solution after. Okay, good. Did you pause it? I hope you did. So let's start by rewriting everything without parentheses. So if there's a negative, we're going to have to distribute that here to the last one. But notice the first 2 polynomials, we don't need to do anything. We can just drop those parentheses. So we've got t squared minus 5t plus 6 plus 5t minus 8 minus t squared minus 3t plus 4. All right, good. Now, this is a polynomial of a single variable, so let's put our answer in descending powers in standard form. So let's look for the highest degree term first. So the highest degree term is 2, right? T squared. So here's a t squared. And then, oh my goodness, here's a negative t squared. That's it. So no more t squareds. Oh no. All right. So this is not going to be degree 2 anymore. Next, let's look for degree 1 terms. So we've got negative 5t plus 5t minus 3t. You guys, the negative 5t and the 5t cancel, right? Boop, boop. So that means we just have negative 3t. And then now it's time for the constants. So we've got 6, negative 8, and 4. So 6 minus 8, that's negative 2, plus 4, that's positive 2. And that is all we are left with. Okay, good job. So that concludes the lesson. Next, we're going to get into multiplication of polynomials, but make sure you're really comfortable combining like terms and not messing with the exponents. Otherwise, moving on to the next lesson might confuse you. Be sure to give this video a thumbs up, share it with your classmates and friends, and feel free to leave me a comment or message me and let me know whatever other topics you'd like to see next.